Hi guys, this is Mr. Myasis here, and I'm going to be going over finding the slope of a line using the slope formula. So in this video, we should be able to, you should be able to find the slope of any line given 2 points. So here are a couple things that you're going to need to write down and know what the slope is. It's the ratio of the change in the y coordinates to the change in the x coordinate. Now, one thing you just need to know is sometimes we call this a rate of change. Okay, so sometimes it's a ratio, and a lot of times we call it a rate of change. This is how does the y coordinate change as the x coordinate changes. We also call this rise over run. In some books you'll see this format. This is a triangle y over triangle x, and that's pronounced delta y over delta x. And delta is just a Greek letter, and it means, and what we use it in math is we mean change. So when you see this delta right here, delta means change. Okay, and delta we can often associate with a difference. So we're subtracting two things. So here's the formula, guys. The slope through 2 points, we're called the first point x1, the second point y1, and the other point x2 and y2. Is y2 minus y1 over x2 minus x1, and that's also called, we say, the rise over the run. Now what I'm going to show you is, I'm going to show you how to do, just plug in the formula, and I'm also going to show what it looks like on a graph and how we can see what that slope is. I call it a slope triangle. So let's take a look at a few examples here. Alright, so find the slope of the line that passes through each pair of points. So I'm going to quickly graph this, and again, if I can get my lines here to work. Oh, look at that. They are not dashed lines today. How beautiful. Okay, so we'll go -2, -3. Plot that point. 4, -6. Plot that point. It's over here. Now, what I could do is from these lines here, I can okay, from this, if I drew a line here, all right, that's all right. Okay, so from this line here, and I should have made this line blue. Let's see if I can turn it blue. Oh, I turned it blue. Okay, so let's see. Well, from this line here, what I'm going to do is I'm going to take this point, and I'm going to just draw straight across, or I can go down, and I'll show that to you in just a second. Straight across and down to the next point, or I can go down. Normally I like to go down. So down and then over. And I've got a little triangle, a right triangle here. I call this a slope triangle. Now how many units did I need to go down? I needed to go down 1, 2, 3 units, right? So I needed to go down 1, 2, 3 units. 1, 2, 3 units. Okay, down is a negative. And then I need to go to the right 1, 2, 3, 4, 5, 6 units. So this is my rise, and this is my run. So if I was going to use the rise, the idea rise over run, I would put -3 over the run, which was 6, which would give me a slope of -1/2. Okay, and this would be my slope. So I can see this visually on my graph, what that slope means in terms of the rise and run if I just count the spaces. Now if I want to use my formula, we're going to say y2 minus y1 over x2 minus x1. And so this first one is x1, and this is y1, and this is x2, and this is y2. So I'm going to go ahead and plug this in. So y2 is -3 minus -6, put this in parentheses. x2 is -2 minus x1, which is 4. Let's do the math here. We got -3 plus 6, because remember we got a negative and a negative. So we're going to have 3 over -6, which, whoa, that is also -1/2. So we end up with the same slope, right, that we got by just looking at it. So either way is going to work. But if you got really large numbers and this is really spread out, then you're going to want to use a slope formula. So I just want to show you visually, but you should be using the slope formula. So as I go on in the next examples, use the slope formula, okay? That's what I'm going to be doing. So here we go. I'm going to run through a lot of examples here. I suggest at any point you pause it, try it out first, and then see how you do it. Okay, here we go. So slope formula. We're going to go, again, x1, y1, x2, y2. So we're going to go negative 1. Remember the formula is y2 minus y1 over x2 minus x1. Or if you're really math inclined, you can use that delta. Alright, so negative 1 minus 5 over 7 minus 7. So we're going to get negative 6 over 0. Ah! Ah! That doesn't work. We can't divide by 0. You can't divide by 0, you'll destroy the earth. So don't do it. So what happens if you divide by 0? We get a slope called undefined. Okay, undefined slope. It's not no slope, it's undefined. And what that means is that I have a vertical line. Okay. So don't forget that. Let's take a look at another example here. All right. So y2 minus y1, y2, y1, x1, x2. x2 minus x1 is 0 over negative 6. Now we can do this. This is 0. We just can't do it the other way around. So the slope is 0. Done. Wow, that was easy. Let's go on to a new one. Okay, let's try these couple. Practice them and see what you can get. Alright, slope is negative 9 minus a negative 6. Remember, we're going y2 minus y1, x2 minus x1. 8 minus 3. That's 5. We're going to get negative 3 over 5. That's our slope. Okay. So if we wanted to graph this line, we can just start at this point and then use our slope triangle that we get from this formula. y2, y1, x2, x1, subtract. We can do it as sing along. 8 minus 5 is 3. Now don't forget, we gotta do that right there. So 0. Ah! Undefined. Oh, you don't have to scream and do all this scribbling on your paper when you get that. Just write undefined. That was for effect for this video. Okay. Uh-oh. I think you need to scream with this one because it's fractions. Let's just go ahead and do the fractions, okay? y2, x2, y1, x1. Oh my goodness, we're gonna have to subtract fractions. Jeez. 3/4 minus negative 5/4. Well, isn't this gonna look fun? Okay, so you know what we'll do here is on the side, we'll go ahead and do this subtraction. Let's do 3/2 minus 1/3, common denominator. So this is gonna be multiplied by 3. Oh, what am I doing here? Sorry about that. Okay, 3 times 2 times 2 is 9/6 minus 2/6, which is going to give us 7/6. Alright, so we have 7/6 on top. Negative 3/4 plus 5/4 is going to give us 2/4, which is 1/2. So 1/2 on the bottom. And when we have a fraction divided by another fraction, we're going to multiply by the reciprocal. Remember that from long ago. And we're going to get 7/3. Okay. Alright, here's the last one here. Last problem example. Find the value of r, so the slope to the line between these 2 points is 5/4. So we know that the slope is equal to negative 5/4. So we're going to go in and we're going to put it in the formula. So y, remember this is y2 and this is x2. And this is y1 and this is x1. So we're going to go negative 8 minus negative 5 over r minus 2. So we're going to get we're going to add this up together, and we're going to get negative 3 over r minus 2 equals negative 5. I'm just going to put the negative up here because it doesn't matter as long as it's one of them. And then we're going to cross multiply. So we're going to do this little heart thing here. Okay, and cross multiply. So 4 times negative 3 is negative 12, and negative 5 times r minus 2. All right, so then we're gonna solve this out. So this is just a single variable equation. 10 right there, plus 10. Subtract 10. It's 22 equals negative 5r, and then divide by negative 5. Seems strange that that's my number, but that is. R equals 22/5. I'm going to go and leave it like that, okay? All right, so that is slope of a line, guys. So we'll see you next time.